All right, today we're going to do a section and a little video lesson here on finding the length of a segment. So really we're going to focus a lot on using Pythagorean theorem and the distance formula, but before we get there, I wanted to just start with the most basic measurement of a segment length. I was doing this with my own kids online for their elementary stuff, so I think this is stuff we're probably familiar with, but I want to start with the most basic and work our way up. So to find the length of a segment, we need to measure, right, to find the length, we're measuring the distance between 2 points. A lot of times we'll see segments that look just like AB, but I mean, it could be, you know, maybe we have, right, a line that goes forever and we're just looking at A and B. So we just want to know the length of this part right here. So you might see it, you know, in different ways, but it's going to be the distance between whatever 2 points are indicated in the name of the segment. So example 1, find the length of the segment between point A and point B. So I can see A starts here at 3 and finishes at 5.5. So that would be 2.5, and this is actually, if I look closely, measured in millimeters, not inches. So the length of AB equals 2.5 millimeters, are the units here. So remember, we did this quite a bit in Unit 7, dealing with the difference between the name of the segment and the length of the segment. But AB with the bar on top, that's the name. So I don't want to say AB with the bar equals 2.5, I would say AB equals 2.5 millimeters. Okay, so just reminding ourselves of some of the notation and things. Okay, example 2, this is going to start to work towards our coordinate geometry here. So we're, instead of measuring things out in space or on a ruler, or on a number line even, we're going to measure them on the coordinate plane, on the graph. So find the length of a segment on the coordinate plane with endpoints A, -3, 3, and B, 3, 3. So A is at -3, so 1, 2, 3 to the left and up 3. So there's point A, and point B, 3, so 1, 2, 3, 1, 2, 3. So AB, and it's a segment, so I'm going to connect those like so. And it asked me to find the length of the segment. Well, just like we did up above, we're just going to measure how many units are in between the 2 points. So I can see here 1, 2, 3, 4, 5, 6. There's 6 units between AB. So I would say AB equals 6. I do not want to say like this, AB equals 6, because AB with the bar, that's indicating the name of the segment, not the length. So, you know, I wasn't too big a stickler for that in Unit 7 because we're just learning about it, but we should start to get that notation down now. So find the length of the segment on a coordinate plane. Pretty straightforward, right? Okay, so time for reality to kick in here. Most of the time, the segments that we see, they're not going to be horizontal or vertical, where we are just able to measure along the line, right? They're going to end up they're going to be segments that have some positive or negative slope. They're going to be slanted lines, and we're not going to be able to count because they're not going to follow the number line exactly. So when this happens, we need to use everyone's favorite Pythagorean theorem. Okay, so Pythagorean theorem and slope, intercept form, those are two things. You'll be an old man like me, and those are the only things you'll remember from Math 1, maybe, like, you know, y equals mx plus b, and Pythagorean theorem, which is a squared plus b squared equals c squared. So it's really important, right, that we understand when Pythagorean theorem is and can be used, right? So this is true for right triangles, right? So right triangles meaning they have one right angle. So I look there and I see this one has a right triangle. So a 90-degree angle is a right triangle, means it's a right triangle. So then I can use Pythagorean theorem. A squared plus b squared equals c squared. And A and B are the legs of the triangle. C is the hypotenuse. And that really means the length of those right here, right? So if I look at this right triangle we have here, we could call this A and this B and this C. And those letters are referring to the length. They're going to be numbers that represent how long this side is. And this is going to be important when we start to do this on the coordinate plane. You're going to not always want to count how long it is, but be able to use the numbers of the coordinates to figure out how long it is. That's going to make our life easier so we don't have to graph it all the time eventually. Okay, so Pythagorean theorem, a squared plus b squared equals c squared. That's true for right triangles, right? So if there's a 90-degree angle in there, A and B are the legs, right? And C is the hypotenuse. The hypotenuse is the side across from the 90-degree angle. Right, so there's my, if I look across from my 90-degree angle, there's my C, that's my hypotenuse. So it doesn't matter which one you call A and B, but the C must be the long side, the longest side across from the 90. All right, so, well, let's just jump into one and we'll see, right? So I was going to do an example with the numbers, but I think it'll be just easier if we kind of do it within the context of one of our examples. So number 3, find the length of a segment with endpoints -2, -5. So I know I have one point here at -2, -5, and I have another point here at 1, -1. And I can connect those. Actually, I'm going to use a different color. Right, so I want to know how long that pink segment is. I can't count, right? I can't say it's a 1, 2, 3, 4 units or something. I don't know because it's not following one of the grid lines, right? So I have to do something a little bit more creative. I'm going to create a triangle like this, right? This side would be A, this side would be B, and this side would be C. Stop the paper there. So I can use Pythagorean theorem to find out how long C is, because I know A squared plus B squared equals C squared because I created a right triangle. So A is 1, 2, 3 units long. So A is 3. And B is 1, 2, 3, 4 units long. So the B is equal to 4. And the C, I said I can't count because it's diagonal, so I have to plug in the A and the B and see what I get. So A is 3, so A squared. B was 4, so I plug, where I see B, I put the 4 in, squared equals C squared. So 3 squared, 3 times 3 is 9. 4 squared, 4 times 4 is 16. So I'm just doing a little arithmetic here. Then I add these together. 16 and 9 is 25. So 25 equals C squared. All right, so I don't want C squared. I want C. So I have to undo, right? That's what we do when we solve these equations. We're undoing all this stuff. So really we're undoing PEMDAS, doing it in reverse. So C squared, I want to undo squaring. The inverse operation to get rid of a square is to take a square root. That'll cancel that out and leave me with just C. And if I do it to one side, I have to do it to the other side. So C equals 5. Right? What number times itself would give me 25? Right? And we're measuring things, so it's only going to be positives, right? -5 times -5 would also give me 25, but that's not going to work here because we're measuring how long something is. We're not going to have negative distances. So C is 5. It's 5 units. So I would say we'll do one more that's very similar. This is going to be the most important part of this lesson right here, being able to do these things right here. So I'll put a star on it. For my class, I put a star by the most important. All right, so example 4, find the length of a segment with endpoints at 1, 1. So I'm going to go 1, 1, and -3, -5. So -1, 2, 3, and then down 5. So I graph those. And find the length of those right there. So we're really going to do something similar to what we did last time. We're going to make our triangle. That would be A, that would be B, that would be C. A is 1, 2, 3, 4 units. B is 1, 2, 3, 4, 5, 6. Let me double check there. 1, 2, 3, 4, 5. Yep, 6 units. And C, right, I can't count because it's diagonal. So I'm going to use my Pythagorean theorem. A squared plus B squared equals C squared. And I'm going to plug in the things I know, right? So A is 4. So A squared is 4 squared. Plus B is 6 squared equals C squared. And now I'm just going to solve for the C. So I got to square this right here is 16. 6 times 6 is 36. 36 and 16 be 36, 46, 52. So C squared is 52. So we did the exact same thing we did on this other one, or the previous one, number 3. We got all the way to the end, and now again, we don't want to know what C squared is. I want to know what C is. So I have to take the square root of C squared to undo the squaring, and I do the same on the other side. So C equals, right, there's no whole number that I can multiply by itself and get 52s, or get 52, right? 7 times 7 is 49, 8 times 8 is 64, so there's no number that's exactly going to give me 52. So my answer would be the square root of 52. Right? If I plug that in a calculator, it will give me a decimal, 7 point something, that's going to come out. You know, if I multiplied that decimal by itself, it would give me 52. But if you do that, that's fine. But typically, we don't want to create decimals. We'd rather just leave it like that. It's the most accurate answer. Okay, so again, I'm going to put a star because that's really the stuff we have to know how to do for this unit. Be able to, or this particular section of the unit. So being able to find the distance between 2 points using Pythagorean theorem. Now I'm going to go a little bit further. So example number 3 and number 4, that's like the have to. That's what you have to be able to do. I'm going to go like one step further. If you're a little confused with this next section, it's okay. Just know that, you know, this is something that may be a little bit more convenient for you. So just like when we did the midpoint the other day, it may not always be convenient to graph your points, right? So here we graphed points and we drew a triangle. Well, what if I have points that are really far apart? You know, what if I tell you that the coordinates are like 57, -13, right? That's not going to fit on that graph. What do I do? Well, you can actually take the Pythagorean theorem and you can rewrite it to get the C by itself. And then you end up with something that looks, when I say rewrite it, right? So if I have A squared plus B squared equals C squared, right? When I think of what I did to get the C by itself was I took the square root of both sides at the end. Well, what if I did that at the beginning? I'd have something that looks like this, right? C, the long side, the distance of that hypotenuse was the square root of A squared plus B squared. And that's really what this distance formula tells me right here. This is A and this is B. if I want to know how long A is, right? If I wanted to know how long this segment is right here on A, I could take the x coordinate of the 2 points and subtract them, right? The difference, right? And if I look at that one, right, the x coordinate is 1 and the x coordinate is -3. 1 minus -3 becomes 1 plus 3 is 4. And I could do the same thing here. If I want to do how long the B was, right, I could take the y coordinate. The y coordinate of this one was 1, and the y coordinate of the purple one was 5, and I could subtract them. Right, it was -5, sorry. 1 minus -5 becomes 1 plus 5 is 6, right? That's what I got there. So I'm going to kind of skip the derivation of the formula there and just kind of apply it in an example, and I think you'll see. So if you like formulas, this is going to be probably more your speed. So the distance formula tells me the distance between 2 points, right? So if I want to know how long that segment is right there, right, there's going to be a point on each end. This one would be x1, y1, the first point, and this would be x2, y2. This side was A, this side was B. Well, A, if I want to know how long A is, I'm going to subtract the x terms, x2 minus x1. And if I want to know how long B is, I have to take y2 minus y1. Right? And by doing that, it's going to create this formula that we see over here. Okay, so I know that may be a little bit confusing, but you'll see here it's not too bad in actual practice. So find the distance between 2 points, R and S. So I have 2 points, R, this is my first point, and S, that's my second point. So I'm going to call -2, -5, right? The x coordinate of the first term is -2. The y coordinate of the first term is -5. The x coordinate of the second term is 1. The y coordinate of the second term is -1. So I'm just going to label them. It's the first thing I'm going to do. And then I can use my formula. Right? So I know the distance between those 2 points is the square root of x2 minus x1 squared. Right? That's kind of like a squared plus b squared was y2 minus y1 squared. So that's my formula, and I'm just going to plug things in here. So the square root of x2 minus x1, so 1 minus -2. Right, so I have to do that squared plus y2, just -1, minus y1, which is -5. Okay, so I picked these numbers purposely so you can see I know from experience that students are going to make mistakes using this formula by forgetting the signs or forgetting to combine the signs or squaring things before doing the order of operations incorrectly, right? So we want to make sure we write it the right way. So anytime I plug in, we could kind of put a parentheses around what we have. I think that's a good habit to get into also. So I end up with square root of 1 minus -2, right? 2 negatives becomes a plus. So 1 plus 2 is 3 squared plus -1 minus -5. So remember, double negative becomes a plus. -1 plus 5 is 4 squared. Right? 3 squared is 9. 4 squared is 16. If I add them together, I get 25. Square root of 25 is 5. So if maybe you caught this, I'm not sure. I did it on purpose, right? To do the same problem 2 different ways. Example 3. Example 3, right? You can see we used Pythagorean theorem and we got 5. I used the same exact coordinates for example number 5 and we got the same answer, but we used the formula, right? So the benefit of doing it this way in example 5 with the distance formula is that you don't need to have a graph available to you. You don't have to graph anything. You can just plug in the numbers and go. Okay, the downside is if you have negative numbers like I chose here, you're going to have to do a little finagling with those to make sure your signs are correct. All right, so last one. Find the distance between these 2 points, J and K, 25, -11, 21, -16. So I picked big numbers. They're probably not going to fit on any of the graphs you're going to see. You've got to use distance formula. So I'm just going to write down the distance formula. Y2 minus Y1 squared. So there's my distance formula. I'm going to plug in, right? I can see there's 4 numbers here, x1, x2, y1, y2. Those are the 4 numbers I got to plug in, so I got to label these. Right? This is x1 and y1, the x and the y of the first term. This is x2 and y2. So I have to plug those numbers in. So d equals the square root of x2 is 21 minus x1 is 25 squared plus y2 is -16 minus y1 is -11. So minus -11 squared. So you can see right here, right, 2 negatives, that's the part I would be looking for if I'm grading a homework or a test or a quiz. That's where I'm expecting a mistake to happen. If one's likely to happen, it's going to be right there. So I can go ahead and keep simplifying, right? If I have one of those nice yellow calculators at school, or maybe you have something similar at home where you could use an app on your phone, I'm sure, right? You could kind of plug this in and you don't have to go step by step to do the calculation. You can actually plug in that whole thing you see right here. It'll give you the answer. But we'll do it by hand. 21 minus 25 is -4 squared plus -16 minus -11. So 2 negatives makes a plus, right? So that would be 11 minus 16 is -5 squared. See, I got negatives in there. But that's okay, because when we square a negative, it becomes positive. So -4 times -4 is 16. -5 times -5 is positive 25. So my final answer, the square root of 25 and 16, 25, 35, 41. That's not a number that I can simplify to a whole number. I don't want to make it a decimal. That's my final answer. So the distance between them is the square root of 41 units. So 6 times 6 is 36, 7 times 7 is 49, so it's between 6 and 7, 6 point something. All right, so we went a little bit over time doing distance formula practice, because that's something that is good to know. The have-tos, the have-tos are number 3 and number 4. And we should be able to measure things straight, that's a given, right? But so things we really have to practice. Number 3, using Pythagorean theorem. Whoops. And number 4, using Pythagorean theorem. Same problem, but one we were able to simplify the answer all the way, and one we had to leave as a radical. Right? Radical is just another word for square root sign. So if you see it's the answer say leave it in radical form, that means leave it like this, don't make it a decimal. Okay, I'm going to stop this one here. Got a little long. Hopefully that gets you set up to do some good work on our homework assignments.